So in this video, we're going to look a little more deeply at what happens as to the current and the voltage as it hits resistors in a circuit. So the first one says, well, what current flows through each resistor in the following circuit? Now we see there's two resistors, so we can be pretty certain that we have to find the equivalent resistance. And they're each a 100 ohm resistor. So 100 plus 100 is 200. Now to get the current, we'll use V equals IR, and I is V over R, or 24 over 200, which is 0.120 amps. So that's the same current going through both bulbs. Both bulbs will appear equally bright, and even over here, it's still 0.12 amps. Now, an interesting question is, well, what happens to the voltage here? So let's take a look. Let's just look at the voltage drop across the first resistor. Now the current, it's just V equals IR. The current through the first resistor is the 0.12 amps. And it's a 100 ohm resistor. So V for the first is 12 volts. Drop. That's a drop. I guess I should make it delta V. Then the change in voltage for the second is still IR. In series, they both have the same current. The 0.12 amps flows through both, and this is 100. So that's 12 volts again. So what's happening here? Here's the positive end of the battery, and then here's the negative end of the battery. So what's going on here is it's 24 volts when it comes out of that battery. So right here, and they'll often ask this in problems, different high school and college problems, they'll say, what's the voltage at each point? So the voltage is 24 volts there. We calculated that after the first resistor, it drops by 12. So the voltage is only 12 volts at this middle wire, middle point here. Then we calculate it drops another 12 volts. So I have to subtract out another 12 volts. And it's not surprising, just like we would expect. It's 0 volts going back into the battery then. And the battery will charge it up. We use the example of the spinner thing in a Hot Wheels or a Matchbox car set, you know, where the spinner thing gives it some speed and it goes around the track again. All right, well, let's try another one that's similar, but in this case, they're two different resistors. So we see that first it hits a 400 ohm resistor and then a 290 ohm resistor. So to get the equivalent resistance, we just do 400 plus 290 gets us 690 ohms. You almost always have to find the equivalent resistance. Now we can get the current from V equals IR, from Ohm's law. Now this is a 12 volt battery. That's like a car battery. The resistance was 690 ohms. So the current is 0.0174 amps. Now we've got to get the voltage drop across each resistor. So let's see what's going on there. The current is the same all the way through the circuit. The current is exactly the same. In fact, maybe I'll do this in a different color because it might be easier to see when I label it on the diagram there. Let's do it in a blue here. Yeah. So let's see what the change in voltage, the voltage drop is across the 400 ohm resistor. V equals IR. They both have the identical current flowing through them. But the first one has a voltage, or a resistance rather, of 400. So 0.0174 times 400, I don't know what that is, of course, off the top of my head. It's a 6.96 volt drop. Then the change in voltage across the 290, it's still IR, 0.0174 times 290. Let's see what that works out to. Voltage drop of 5.05. Make it 5.04 because then it'll be more even. Okay, so let's see what's going on. I'm just going to make a little room up here just to erase some of this for right now. You can always go back and view it if you like. Coming out of the battery, it's 12 volts. So it's 12 volts at point A, it's 12 volts there at point E there. But some of that voltage is going to be lost going over that resistor. So we have to do 12 minus 6.96. I'll put that right there. So at point B, the voltage has dropped to only 5.04 volts. Then at point C, I think we can see 5.04 minus 5.04 is 0 volts. And it's also 0 volts at point D, and here at point E it's 0.12. We don't really need those on the bottom so much. So the voltage is high, then it goes through this resistor and drops a bit. Then it goes through this resistor and drops a little bit more. Let's see another example of that on the next slide. Oh, same thing. This is just showing you the graph, how the voltage starts off high, and then drops, and then once it hits the battery again. And there's two drops. This is the 400 ohm resistor, and this is the 290 ohm resistor. And this is the same math that I just showed you. Now let's do one in parallel to wrap up today. So the first thing we have to do, just like always, is get the equivalent resistance. But in this case, if we look at the picture, they are in parallel. So unfortunately, we need to use the reciprocal formula. We get an equivalent resistance of 50 ohms. Now we're going to get the currents. So V equals IR, and this is going to be the total. So I total is V over R equivalent. 24 volts, that must be 2 car batteries, over 50. And yeah, that's 0.48 amps. So this I in the top wire is 0.48 amps. But if we pretend it's water, if water had 2 ways to go, it would pick one of the two. It would have to, I shouldn't say it would pick, it would split into one of the two. The current would be less. Now, if we remember, in parallel, the change in voltage is the same. So to get the current through R1, it's V over R1. And the voltage is still 24 volts divided by 100 in this case. That's 0.24 amps. So this is 24 volts over here like we saw in the last problem. This is 0 volts over here. And it's exactly the same for this parallel one. It's 24 volts here and 0 volts there. So the current drop, or the current rather going through I2, it's not a drop, is V over R2. Or 24 over 100, which is 0.24 amps. We could add those two. And when we add those two, we get 0.48 amps. Kind of makes sense. It comes out at 0.48 amps and it splits. It sends 0.24 amps through here and 0.24 amps through there. It's kind of like the water. If it were 48 gallons per minute, it could send 24 gallons per minute this way, 24 gallons per this way. Now over here, these will recombine. And when it comes back to the battery, it'll be 0.48 amps, like the 48 gallons per minute. All the currents have to add up to be that total current.